Hey, welcome back. So in our last video, we completed my program counter on a breadboard. And in this one, I'm going to want to transfer this to a Perfboard. So let's get started. Okay, so in order to transfer this to a Perfboard, this is the one I will be using. It says it's 54 by 27. Copper on one side. This is the perforated hole, so none of them are connected, so they're all just individual dots. Now, I've spent so many hours agonizing over how I want this to look. I even went on to Easy EDA and built a schematic, and you can see my issue is that there are just so many wires. With a breadboard, you can make a mess of wires, and it's kind of okay. With a Perfboard, you want to try to minimize as much as you can the crossing of wires and the mess it's going to make. So what I like to do is kind of lay it out beforehand. So this gives me an idea of what I'm going to be working towards, but let's actually lay it out with the components first and then start planning this out. So let's do that. So I have all the components laid out here from the EasyEDA tool. So I have my IC headers, so let's place those in the middle. That's easy. Dip switch on this side because the bus will be on here on this side. So now I'm going to have a bus in and a bus out. So one that's going to connect to the bus and one that's going to connect to the instruction register. So the way this is going to be oriented, it's going to be least significant bit here, and these will be the two counters, and this will be the two selectors. So I will be loading in from this side and outputting to this side. I think I want to output low and have the LEDs on between the output pins to the instruction register and the selector pins. So I'm not even worried about where it's going to output yet. I'm just going to try to fit these in. Okay, looks like it could work. I'm also going to want to have my switch up here, give or take. And I also have a RGB LED that I'll use for green red to indicate whether it's in run mode or program mode. I'll just snip off the blue LED. I don't need that one. Okay, that should work. And I'll need a resistor between there because there will be direct current. So that should be somewhat what my layout's going to look like. No, I'm missing a couple of pieces. No, I'm going to need my clock and clear line. I'm going to need a load line as well. So this will be my load instruction from the instruction register. And then clock and clear in here, output, input, and then I got to connect all of these. So I'm going to have bit 1, 2, 3, 4, 5, 6, 7, 8 coming into these selectors as, it doesn't really matter, so just to be consistent, or inconsistent this time I guess, but more convenient, I'll be 1, 2, 3, 4, 5, 6, 7, 8. So, all right, now for the soldering. Now before you start any soldering, it's important to have proper ventilation, but more importantly is an ice cold glass of homebrew beer. So this is a IPA I made myself out of rye, and this will help me get through all the soldering. So cheers. Okay, let's get down to it. I'm just gonna pull some of these more loose parts out and do them later. Okay, so let's start with this one. So what I do is just tin 2 of them and then hold into place later, so watch. So with that, I can kind of even out a bit now by holding my finger on it and just tapping it. Okay, that's now in. I can do the other side. Just applying pressure from the other side of the board. Okay, nice and flush. There we go. Let's do the dip switches. There you go, heard that click. Nice and firm now. Okay, so all those are in enough for now. They won't fall out. I can move them later if I need to because they're just barely touched in there. Let's put the LEDs in. I'm putting the long leg of the LED in, pointing towards the IC chip. Now same thing with this. I'm just going to touch one of the LED pieces and then I'll adjust them later with a little bending, make them look pretty. This is just to hold them in. Those are held in now. I'll fix them up later. Now let's put the header pins in. Now I just want to basically straighten this out and center it with those two pins. So I'm going to hold the top and just touch the bottom. Straighten it out. Looks okay. Okay, that looks better. Let's do the little ones. So the clear and clock. And now the load signal. Pretty firm, I can solder that later. And then I'll solder in this, this is a 300 ohm resistor just to not burn out my LED. Okay. So it's reasonably good. I can probably straighten out some of these LEDs now while I have it mostly together. Okay, I'm happy with that. All right, so now I'm going to start laying out the underside to see how I can run these traces. Okay, now it's time for some planning. As you can see, this is a jumbled mess, and this does not need to be. So even on my easy EDA sketch, you can see there's a lot of crossing wires, which is not ideal because this is a one-sided plane. But because I'm doing this the way I want to do it, I'm going to actually make this a two-sided plane. So I'm going to use the top and the bottom. But I'm going to keep the top focused on aesthetics if I can. So silver copper wire, straight lines, no windy, no crossing, just nice clean lines. So for anything in this description that seems pretty clean, I think I'm going to do it on the top, and all the dirty stuff I'll do on the bottom. So obvious ones are the bus in, because that's just 1, 2, 3, 4, 5, 6, 7, 8. That look pretty cool, like a wave out. I'm also going to need the lower bits, right? Because I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 7, 8 can go across here. And same with the dip switches. I can make some silver copper lines out of here into these, which would be pretty cool looking. So at least start with that. I can tie these clocks together up down below, because that would be crossing these silver copper lines. So I think that would be a good start. I generally like to do the power and ground at the end. I know a lot of people like to do it in the beginning, but as you can see, we got the 5-volt coming across the whole way here, and the ground, same thing, needs to be everywhere. So I just like to do red and black insulated wire for that, because it's just so hard to plan otherwise. So that's what I'm going to go with, and I'm sorry if it's not the most efficient way, but it's the way I find best. So I'm going to do as many in the top plane as I can first, then simple ones on the bottom plane, and then I will use some jump wires where necessary. So let's get the fan on, let's get some soldering done, let's have some fun. But much more importantly, to all you out there, it's Friday night, cheers. Okay, so you can see that came out pretty good. I have the 8 bits coming in. So let's do the 4 lower bits here I can do. Okay, let's start on the dip switches. I can do bits 3, 4, 7, and 8 up top right here. So let's do that. Not my best work, but it came out okay. Okay, now that we have this top part looking pretty good, let's flip it over and start soldering permanently the rest of these, and then start getting these wires bent over and soldered together. So let the soldering begin. Okay, got it all set up in my helping hands. Now what I want to do is finish soldering the items that we started soldering in the corners, finish them all up, and then you can see I've bent over all these ends. I can just use those to connect a lot of the various pieces. So not the LEDs just yet, but a lot of the items I've bent over I can actually connect to where I want them to be connected to. So I'm not going to talk for a bit while I finish all this, and then I'll come back to you after I've gotten most of the items I can solder together. So time lapse. Okay, so the next thing I want to do is quickly, since I have these LED leads in the way, I'm just going to connect the ones I can right now. So the first LED should go to this pin, pin 7. 1, 2, 3, 4, 5, yeah, 7. So that goes to here. So I'm going to solder that one in. And the next LED goes to pin 654 right here. So 7654 right there. So I can solder those two in and snip the other two out of the way. Same with this one. It's going to go to pin 7 on this chip. And the one next to it to pin 4. Bend it around this other one like so. So I'm going to solder those two in really fast. Or those 4 in. Okay, so the rest of these LEDs, LED 3, 4, 7, and 8, I had to go onto this side. So I'm going to solder in these leads, snip them off, and then put jumper wires over to the side. So let's do that right now. Okay, so now what I have to do is hook up, I have bits 1 and 2, 7 and 8 on this side, and I have 3 and 4, no sorry, 1 and 2, and then 5 and 6 on this side, and I have 3 and 4 and 7 and 8 on this side, so I need to hook up the other 8 bits on the back side. So that means I need to hook up bit 3, which is here, to the selector up here. And you hook up here to here. So I'm going to create jumpers from here to here, here to here, and then on this one it's here to here and here to here. So let's get those jumpers measured out and then I'll put them over. Okay, so I just described that, and the reason I hesitated while describing it is because I messed up. So you can see I have bits 7 and 8 here hooked up to 5 and 6. So I had to remove these 2 bottom wires, and that one is right, but these 2 should be in bits 5 and 6, not 7 and 8. So I had to shift these over by 2. So that's the problem with Perfboard. It's not as easy as breadboard to just move things over, so let's do it. So it's not pretty, but that is now going to that. That is now going to that, and that's just a waste of glob. So, all right, so I think we're good now. Let's finish my jumping. Okay, I think that went reasonably well. I got them all in there. It's kind of hard to see, but yeah, they're all in there now. I'll be doing a lot of testing before I do anything. I'll be using the multimeter to test this very shortly, but let's keep going. So now that I have the 8 bits wired up, 4 on the top, 4 on the bottom, I'm going to try and wire the remaining 4 LEDs. So that's these 2 and these 2. So let's get going. Okay, I got the LEDs jumped. Let's do some continuity testing. Okay, so I'm not done yet, but I want to stop now and just take some continuity tests to see if I've bridged anything before I keep finishing up. So let's start. Do the simple ones, let's do the side-by-side. So beep is bad, so if any of these are touching underneath, whoa, that's me touching. Side-by-sides are the most common to get bridged. No, and so all of these should be okay, so that should beep on that one. No, it doesn't. Oh, that's this one, this pin. Yeah, that. And this one, we're to bit 1, bit 2, bit 3, bit 4, yep. Bit 5, bit 6, bit 7, bit 8. Cool, that'll work. Now this should connect to this and nothing else, yep. This should connect to this. This should connect to this. Oh, this is the one I messed up, isn't it? So this one, 1, 2, 3 should connect to this. 1, 2, 3. Did I flip them? I did, didn't I? Yeah, so this should be going here, and that, yeah, I flipped them. Wow, that one was a disaster, wasn't it? So I think if I check, just to double check to make sure I know what I'm fixing. According to this, I connected bit 5, which is here, to bit 6, which would be 1, 2, 3, 4. Fourth over, 1, 2, 3, 4. Yep. And then I bit 7, 6, 2 bit. Yeah, 5. So 6 and 5 are flipped. And this should connect to this. Yeah, and this to this. This to this, and this to this. Okay. Wow, not bad at all. One flip, so let's fix that right quick. Let's try that again. So the issue was on pin 3 of this chip, going to pin 4 of this chip. Good. And then pin 5 of this chip going to pin 2. Yeah, okay. That fixed that. So I don't see any other glaring issues at the moment. Let's continue on. Actually, let's quickly check the result LEDs. So the results should be this one, bit 8 going to, yes, that result, and then 7 should be the 10th pin, yep, 6, yep, 5, 4, 3, 2, 1. All right, those look good too. Okay, so now let's finish up our 74LS163s. We have our clear and our clock lines, which need to be linked together and linked to the headers. So let's start with the clock lines and put them in together really fast with some silver copper wire. So I got both the clocks hooked up, and one of the clears, I need to jump the other clear though because of the that one is blocked in, so I'll jump that one right now. Alright, that did it. Let's do a quick continuity check to make sure we didn't screw anything up too badly. This is the clear line to the first one. Looks good. And the clock line to the second. And the first. And the second clear. No. I have broken the bridge to the first clear. Need to fix that. So check to see if the clock got cross-contaminated. No. And the clock is still good in the first. Good in the second. Clear on the second. Good. Clear in the first. Yep, good. I did it. Okay. Okay, next let's connect back to our old schematic, right? So we need the carry out to carry in, and we need to load this jump to the header pin I put in. So to the carry out to the carry in, and connect the two jumps to the header pin I created. continuity check. Looks good. Okay. Let's do the jump line too. This pin over here is 5 volts. I just tied it thinking it was the jump pin, but it is not. Ugh. All that work for nothing. This is the jump pin. This one. Undo. That's how it's done right. The 4th time. Okay, so now everything else is 5 volts. Actually, I need to jump this over to that still, don't I? Because this is the pin I'm going in. Well, I could move the pin to there. Yeah, I'll do that. There's no reason to put another jump in there. All right, continuity check time. It's not good. See, when you hear a beep like that, it's not good. That's good. That's bad. Yeah, it's not a good connection. Need to get a little better bead on. And clear is, sorry, jump. I keep saying clear, this is jump. Jump is this pin. Oh, good, and this pin. All right, that works. Make sure it's not on the pins next to it. That was good. All right. Okay, so the next thing I want to work on is I have this result output that's going to go to the to memory after the program count is done. So I need to, these LEDs are simply displaying the count. I need to take that signal to this 8-pin header here. So I'm just going to route wires on all of these positives into the 8-pin header here, and then these anodes, well, I'll just tie together and put into ground. So let's do that right now. Bend these up first. Okay, so the next thing I'm going to do, now that I got these pretty much wired up for the LEDs and results, I'm just going to quickly test all the LEDs. So I'm going to hook up all these grounds together, and then put a ground, and then test my connections up top. Let's get it done. Okay, so I'm not sure if you can see that or not, but it looks pretty good. It looks terrible, but it works well. So those are all grounded up, so now I can attach my ground here and a resistor. I can grab a resistor and the positive and just touch each of the outputs of the 74LS163s and to see if they all connect correctly. So let's see if I did okay. Okay, so I'm going to hook up my ground to this little guy here. And put this on top. And I have my power attached to a 300 ohm resistor. I should be able to touch the outputs of each of the 74LS163s, which would light the LED, in theory at least. So no, I can't touch these because it's the selector output I need to touch. Silly. So that's one here, 2, 3, 4, okay. 1, 2, 3, 4. Alright, well that works well. Huh, first try. The next thing I want to do is wire up the last 4 bits of this. If you remember, I've wired the top 4 bits, or not the top 4, but 3, 4, 7, 8 to the top here. I had to wire 1, 2, 5, and 6. And then I'll have my selectors all set up. So let's do that next. So I probably should have done these before the yellow ones, but that's done now because I have bit 1, 2, 5, 6 over here. So 1, 2 needs to go to here and here, and 5 and 6 need to go to here and here. now let's tie all of the bottoms of the dip switches to ground with just some silver copper wire. Okay, to test our dip switches, first let's go to the on position for all of them. And now I have my ground here, which I'll just hold on to in the corner here. And I'll touch each of the inputs. So I think 1 is here, yep. 2, yep. 3, 4, good. And then 5, 6, 7, 8, and test all the negatives. All right, good. Those are good. Now I'll test it all in the off position. This should have no continuity whatsoever. Cool. Dip switch is done. So if you watched this far into the video, it's not going to surprise you to learn that I have made yet another mistake. Not a big one, but I still have a ground pin here and a select pin here that I need to get to that I can't do without removing these wires. So I'm going to remove this yellow one, this green one again. I'll hook up this ground on this chip just to the LED ground, might as well since I have it. I'll grab that select and marry it with this select and put them up here to the button. And those are the two I'm having the hardest time getting to. All the other ones I should be able to get to that problem, but these two I can't get to. So time to desolder, add some wires, and resolder. And that should really be the last of it. Let's go. Let's do the other ground wire now. Okay, got my selectors. All right, let me do my other ones, my 5 volts and my enables. Okay, so now we have all of our signal lines wired up. All we need to do now is set up the enables and the 5 volts and grounds. So we got the grounds on the 2 selectors, the 157s, and we need to do the VCC, which will pull to high, and the enable, which will pull to low on both of these chips. On the 74LS 163s, same thing. I have grounds right here, and then 5 volts up here and here, and then the enable, again, I'm going to pull low. So let's get all of those. Another thing I'm avoiding is where I'm going to put power into this thing. I think this area is nice. I want to keep this open so I can program it. So I'm going to put it probably right here, and then route everything to there. So I'm going to put a little 2-pin header in, and let's get started. Okay, so what I've done there is I've wired up this ground to this ground, bridged it to the enable pin, bridged it to this enable pin because they both enable lows, or active lows, to ground, took the 5 volt to 5 volt, I'm going to tie that one to that one, and then we're going to have those chips done. Okay, let's pull the selector 5 volts, which is this pin, and their enable low as well. Okay, looking pretty good there. Got a couple more cleanup things to do. I got a ground plane here and a ground plane here. I got to connect. Got to get these signal wires done, this button, and then I should be pretty good. I'll do some continuity testing, and then I will put power to it. So let's get the last finishing touches done and see how well we did. Okay, so now time for the switch. Now these switches have 6 pins, which you can see here. These 3 all tie together, and these 3 all tie together, but the top and bottom have nothing to do with each other, so these have no continuity with each other whatsoever. But this pin and this pin are kind of like a common pin, so this top upper right one will either be connected or disconnected to the second or the other 2 pins. So in this situation, the middle pin and the right pin are set up. If I flip the switch, the outer pins will be there and not the inner. So same in the bottom. In this situation, the outer will be connected and the inner won't. So these, the upper right and bottom left, is like your common pin, and the other 2 switch back and forth. So for my purposes, I'm going to have 2 things. I'm going to have my LED up here and my select. So I'm going to tie these 2 select lines to the common pin, so to this right pin over here. I know it's not common, but I don't need a common. So it's either going to be on or off. So I'm going to connect both of them to this one, and then ground to this one. So that will either pull the select pin ground to ground, or it will leave it floating, which on this chip is default high. On the top side, I'm going to tie 5 volts to the upper right pin, which is that common one I spoke about, and I'm going to tie this anode to the middle pin and this anode to the left pin, and I'm going to tie the common pin here to the resistor I have, and the resistor to ground. So that should make it so that this will flip back and forth between 2 colors, and the bottom one will either be grounded or not grounded. So let's get some soldering done. Okay, so see if you can spot what I did wrong. Now I mentioned before that these are always floating high, so now I've tied to high, which is wrong, because it will never go low. So I need to take this red one out and replace it with a black one that goes to ground. So that was a mistake. Shocking, I know. So the mistakes have not yet finished. Okay, these are common anode LEDs, not a common cathode. So I have this to ground, and I need to make this to 5 volts, and this to ground. Again, this to 5 volts, this to ground. So I will be making another adjustment. So bonus material. This is going to be a very long video. I already apologize, and if you're still here, well, God bless you. Okay, so the first test is the easy one. I will just plug it in, and it should, all that should happen, because I haven't chips in yet, is the LED should come on, and I should be able to change the color of the LED. So let's see if I got that part right. What? Red, green, nice, okay. Green is much better than red, but that's because I'm using the same resistor for both. I should be using different ones, but I'm not. So good. That works. Okay, let me get the chips in and see what happens when I do that. Looking pretty good so far. Let's see what we can do. I'm nervous. Okay, here is our test rig. I have my clock. I have one of these little buses I've pulled out of a breadboard, and I have the connections. So the first thing I want to connect is, let's start with the clock pin, which actually I don't even know which one it is. Clock is the left one. Left is clock. So clock. And that would make this clear, which I'm going to pull high because it's an active low and I do not want it to clear. Jump, I'm also going to pull high because I do not want to jump. And then I just have, I'm not going to do anything loading yet, so I'm just going to do, because I'm in jump high, so it won't load, so it should just count. So this is the ground. Okay, let's see what happens. So far nothing. I pulse the clock once. Nothing happens. So I pull my power out. Okay, well, as expected, it's not perfect. We have some kind of short, it seems like. As you can see, my clock is pulsing away because of the power supply I'm using. If I shorted this, it will stop. So when I put my ground in, it's still good. but as soon as I touch that's in, it stops. So I don't know why that's happening. What I'm going to do is pull one chip out at a time and see which chip is wrong, and then from there I will go and figure out what's wrong. So yeah, I don't know why it stops pulsing when I put that in. It shouldn't. Okay, we may have found our culprit. So if I put this one back in, okay, boys and girls, do you remember how I said I was done making mistakes? Oh God, was I wrong. So my big problem is flipping this thing over. You know, I've been working on breadboards for so long that flipping it over is difficult, but here's my problem, right? That's ground, that's VCC, because I have the chip backwards. But when I do it this way, I wired ground to VCC and VCC to ground. So, and I also got my enable wrong. So my enable is tied low, it needs to be tied high. So I need to switch this one, this one, this one, this one, this one, and this one. Can't see the rest of those, but yeah, it's a lot. I need to switch all my VCCs and grounds on these two chips. So I will be doing that right now, and I apologize for this terribly long video that is not very informative. So I hope you had some fun watching it, because I'm not having fun making it. Okay, that wasn't fun, but I think I have fixed it. Let's see. Gosh, that was annoying. Okay, let's see if this still shorts out. Put ground in. I'm gonna put this in. It should at least turn the light on. All right, good, and the clock's still going, so that's a good sign. And can I move these? Yes, 2, 3, 4, 5, 6, 7, 8. All right, cool, all those work. Cool, okay. If I switch though, okay, I haven't plugged anything in yet, so let me plug in the clock we said was on the left. So that is, yeah, this is the clock. Then I can take the jump low, or sorry, high, and the clear high. Oh no, is that counting? Is that actually counting? Speed the clock up a bit. Oh my gosh. That is such a relief. Come on, go all the way up. Just do it. First try. Well, not really first try. No one's going to give me credit for that, I suppose. Whew, that was an adventure. So at least the counting and the dip switches work. Now I'll have to try the loading at some point. Let it reset, and then I will set up a load test. Oh, thank God. Okay, let's set up a load test really fast. Okay, so all I've done is just taken one extra line and put it into the load. Turn the clock back on. Now, let's see, the load bit is this jump one. So if I take this from high to low, cool, there, that one bit is there. So if I move it over one, nice, that works. One more, yep, it's actually working. Oh, no, it's, oh, well, I haven't tied them, other one's high, so it's gonna be some weird data, but as long as I want to put in goes low, that's all that matters. 4 doesn't seem to work. Huh, interesting. One of them, just one doesn't work. Not so bad. Okay, I can see what that one is right now. Well, that's easy one finally. You don't be able to see it on the camera, but the solder joint isn't very good, so I'll just fix that solder joint up right quick. Okay, so try that again. Turn the clock back on, and see if you can see it. 1, yep. 2, 3, 4, yep. Fine, 4 works at time. 5, 6, 7, 8. Now is that a short? No, it's just a bed. That's fine. Because I haven't pulled them high, so that's typical. But yes, it is working. It is absolutely working. We try a clear. So if I put the clock off and pull that down and pulse, and now if I pull clear high, the next clock pulse, not high low, it is high. If I pull it low now and clock pulse, clears, yes. Now if I go back, pulse, perfect. All right, it looks like we have a functioning program counter. That was a very long effort. So I think that's it. Yeah, I learned a ton on this. It was challenging. I hope this was the hardest one, but I doubt it. Had a lot of issues. I hope you learned something from my trials and tribulations. In my next video, I'll be doing a register. I've actually already started it, and the bus, so I have those two coming in the next few videos. So hope to see you then, and leave a comment below. Thanks.